Black soldier fly, or BSF, Hermetia illucens, is more than just an insect. Its larvae are nature's composters, turning agricultural waste into two powerful products: protein-rich larvae for livestock and frass, a high-quality organic fertilizer. In this video, we'll walk you through how we produce BSF frass right here in Iloilo, using a standardized system developed by the Department of Agriculture, Iloilo Research Outreach Station, Cabatuan. The heart of our operation is a controlled BSF rearing facility divided into key areas: the insectarium or fly room, where adult flies mate and lay eggs; the larvarium, where larvae are raised; the production beds, where feeding and bioconversion happen; and dedicated areas for substrate preparation and frass storage. The facility is maintained between 25 and 35 degrees Celsius with a relative humidity of 60 to 70%, conditions that allow BSF larvae to thrive and grow efficiently. In the fly room, adult BSF flies mate naturally. We set up an egg trap, a rearing box with a mesh screen cover, baited with a fermented attractant made from water and dead black soldier fly material, left to ferment for 2 days until it produces the odor that attracts egg-laying females. Female flies deposit their egg clutches into wooden lattice structures placed just above the attractant. These are checked regularly. Once eggs are collected, typically 10 to 12 days after the previous cycle's pre-pupae are placed in the love cage. They're transferred to hatchling containers with rice bran as the initial feed, maintained at 40 to 60% moisture. For feeding, we use two main organic materials as larval feed: coconut dregs or sapal, collected from public markets, and chicken manure from local poultry houses. For the chicken manure, it's air-dried directly from poultry houses, then sieved to remove feathers and foreign objects, and stored under mesh netting to allow excess ammonia to evaporate before use. For the coconut dregs, they're washed with tap water, then fermented for about 5 days and drained for another 3 to 5 days to remove excess oil and water. When the larvae reach 12 days old, they're sieved from the hatchling container and weighed. We transfer 3 grams of larvae into each production bed, together with 300 grams of prepared substrate. Coconut dregs layered first, followed by chicken manure on top. Substrate depth is kept at 2 inches or less to ensure proper aeration. Moisture is maintained at 50 to 70% through daily spraying with tap water. An additional 300 grams of substrate is added after 5 days to continue feeding. Larvae feed actively for a total of 14 days on the substrate. The entire cycle, from egg to harvest, is completed in 21 days. After 19 to 21 days, the larvae begin to darken in color, turning brownish to black, signaling they're entering the prepupae stage and are ready for harvest. Larvae are sieved out using a wire mesh screen and manually sorted. The harvested prepupae are then set aside as breeders to continue the next cycle. Frass is harvested the same day using a finer mesh screen, 0.35 millimeter diameter, and collected into storage tubs. The harvested frass is then ready for nutrient analysis, drying, and application as organic fertilizer. Black soldier fly production is more than a farming technique. It's a closed-loop solution to some of agriculture's most pressing challenges: waste, cost, and sustainability. By converting coconut dregs and chicken manure into high-quality frass, and protein-rich larvae. We're turning what was once considered waste into valuable farm inputs. Right here in Iloilo, using a system that any farmer or agri-enterprise can replicate. Whether you're a smallholder looking to reduce input costs or an agribusiness exploring sustainable solutions, BSF technology offers a proven, science-backed pathway forward. For more information on the standardized BSF production protocol, kindly reach out to Department of Agriculture Iloilo Research Outreach Station Cabatuan. Together, let's convert waste to resources to build a more sustainable future for Philippine agriculture.